Alright, let's look at Theorem 1. It's called the Inscribed Angle Theorem, right? Which states this. If angle ABC is inscribed in a circle centered at O with radius R, then the measure of that inscribed angle ABC is 1/2 of the measure of the intercepted arc. Right, so let's do that. Alright, so we just need to kind of generalize the lemma we just did. Alright, so here's the situation. So there we can think of three different cases. And the first one, depending in terms of the location of the center O. Right, let's say O happens to be on the angle ABC, which means that it's one of the sides. Right, so without loss of generality, we can just say O is going to be on BC. So ray BC, so B is probably over there, and C is there, and probably I'm just going to draw a random picture here, and here is A there, right? But this looks familiar. This is right back to the situation in lemma that we just talked about. So therefore, we know that the measure of the angle, ABC is definitely 1/2 of the measure of the arc AC. So this is by lemma, because it's exactly the same situation, right? And the second case, let's say a center is not on any of the sides of the angle, so it's got to be either inside the interior of the angle or the exterior of the angle. So let's do the interior. So you have two more cases would be this is going to be the interior of the angle ABC, or the exterior of the angle ABC. Alright, so let's look at case 2. So if it's the interior, so that means that so B is here, but A is going to be up here, and the C is going to be down here. Alright, so this would be A, that'll be C. Right? So what we can do is we can construct the diameter from B through the center, and wherever it hits the circle, we're gonna call this guy D. Right? Then we can see that here, measure of the angle ABC, which we're interested in, right? But the BD is going to be interior of this angle, so we know that this is going to split into measure of the angle ABD plus measure of the angle DBC. Right? So this is by angle axiom 2, I believe. Alright, but for each one, for each angle, one of the sides go through the center O, so we can apply the lemma back then. So you have, according to lemma, this is going to be 1/2 of the measure of the intercepted arc. So for that guy, ABD, intercepted arc would be arc AD. Right? Plus 1/2 of measure by DBC. Again, DB goes through the center, so it's a measure of the arc DC. Right? But combine those guys together, it's a 1/2. Measure of AD plus measure of DC is obviously measure of AC. Right? So that will checks out. So this is good and that's good. Alright. Then what about the case where the center sits in the exterior of the angle? So you're going to have a picture which looks probably something like this. Right, so this is going to be our A, and this is B, and this is C. right? Then we're going to do the similar construction. We're going to construct the diameter here and call that guy D, right? The same way. So you can see that the measure of the angle ABC is the measure of the angle ABD. Then you have to subtract measure of the angle CBD, right? But the measure of the angle ABD is same as 1/2 of the measure of the arc AD. Subtract 1/2 of measure of the arc CD, right? But the 1/2 pulled out, but the measure of arc AD minus measure of the arc CD would be measure of the arc AC, right? So therefore, this is exactly what we wanted to get, right? So all three cases, we end up having the same equation. Measure of the inscribed angle is always 1/2 of the corresponding measure of the corresponding inscribed arc, right? Or I should say intercepted arc, right? Right, that's called the inscribed angle theorem, right? That's it. I hope that this was clear.